Correct. So our lesson for today is regarding linear and angular speeds. Your aim is how do we find linear and angular speeds? And can someone read the do now here? The highlighted text.
A winch, is that how I say it? A winch of radius 2 feet is used to lift heavy loads. If the winch makes 8 revolutions every 15 seconds, find the speed at which the load is rising. Use the formula speed equals distance over time.
All right, so thank you for that. So yeah, just a winch is the tool seen here in this diagram, and our given information is that the radius of this winch is 2 feet, and it makes 8 revolutions every 15 seconds. So see if you can find the speed at which this this load is rising. Okay, so take like a minute, and then we'll go over it. Okay, so if you didn't come up with anything, that's okay, but just want to keep the lesson moving. Did anyone come up with an answer? If not, then that's okay. I'll just show you the solution. Okay, so I'm going to scroll up for this. Oh, Dorothea, yeah, good.
I don't know if this is right, but I got like 2.1 feet per second.
2.1. Okay. I don't remember if that's the correct answer, but I'm going to scroll up. It might be, maybe. Let me see though. So, okay, so it ended up being 32 pi over 15. If you calculate that though, that'll come out to 6.7. So maybe, did you multiply by pi?
Yeah, I forgot to do that. My bad.
Okay, yeah, that's okay. But yeah, good job getting the initial, that 2.1 number. Okay. All right. So the way we're going to do this problem is use the speed equals distance over time formula. And the trick to this question is just calculating the distance. Okay. So the distance is equal to the distance that a point on the winch travels. So note that this is a circle, right? So it says it makes 8 revolutions every 15 seconds. So at that point, we just have to think, what's the distance that a point on this circle travels? Well, the distance that a point on the circle travels, another way to say that is the circumference of the circle, right? The circumference being the perimeter of the circle. So the circumference will be 2 pi r. Radius is 2 feet in this case, right? So, and we're given that it's 8 revolutions every 15 seconds. So 8 revolutions times 2 pi r, that's the distance that a point travels, right? And then divide that by 15 seconds. If you multiply that out, you're going to get 32 pi over 15 feet per second, which is about 6.7 feet per second. Did anyone have questions about this? Or is anyone copying this down? No? Okay. If not, I'll keep moving. Okay. All right. So again, today we're going to talk about two major concepts. The first being linear speed. The second is angular speed. Okay. I'll highlight what I want you to copy down. Okay. So this first example, so I won't go through the slides here because the responses should be pretty quick. So I don't want to like go back and forth between the slides and the lesson plan. So I'll just show you the lesson plan. Zoom in. Okay, so given a wheel, define what linear speed is. Okay, so as we denoted from the do now, right, linear speed is the distance one point on the wheel travels over a set period of time. Okay, so just focus on one point, and then the distance that that point travels is the linear distance, over time. Okay, but the distance around the wheel, you have to think about that a little bit more. And as we did so in the do now, we know that the circumference is the distance around the wheel, right? And the circumference is 2 pi r, as we know. where r is the radius. Okay. Now, what I actually want you to copy down is the following. So speed is distance over time, and I'm going to be more precise about that. When they say speed, if they don't mention either linear and angular speed, because remember, those are the two different types of speeds we're going to talk about today. If they don't specify, then just assume it's linear speed. Okay. But here's the formula. So linear speed is linear distance over time. And the way we're going to calculate linear distance is the number of revolutions times 2 pi r, right? 2 pi r being the circumference, divided by time. Okay. And another way to write the numerator is arc length. Okay, so number of revolutions times 2 pi r, that's the distance around a circle, which is arc length. And if you remember, the letter we use for that is s. So it's s over t. Okay. So again, please do copy this highlighted text down. You're going to be seeing this formula a lot for these types of questions. Okay. All right, and then after you copy down this text, please copy down this also. So there's nothing much to this besides, just changing the letters. So linear speed, we normally use the letter V, and you might have already seen that in physics class, right? So V, usually denotes a velocity, which I know is different from speed, but this is the letter that the textbook uses, so we'll be consistent with that. All right, does anyone still need this? Please speak up or type in the chat. No? Okay. All right, if not, then I'll move on to the next concept, which is angular speed. Okay, so the follow-up question here was, given a wheel, define what angular speed is as opposed to linear speed. Okay, angular speed is the rate, excuse me. Angular speed is the rate at which the central angle is changing. Okay, so meaning it's like rotation, like how fast something rotates, right? So you imagine like a CD or like a Frisbee, right? So they rotate, right? Or like a disc, right? It's how fast the central angle is changing, okay? Now, what I want you to copy down is this following formula. And yeah, actually, well, this definition is actually, that would be good to copy too, because angular speed, you might not have seen it in physics class yet. I think you'll get to it in a later unit, but yeah, so copy down this definition here, as well as this formula. And I'll add on this too, this last one. Yeah, let me talk a little bit more about what the formula entails. So angular distance is the number of revolutions. So in linear speed, the next part was 2 pi r, right, which is the circumference. But for angular speed, it's 2 pi radians, okay, because 2 pi radians is a full rotation. That's the same thing as 360 degrees, right? So for one full revolution, any circle would rotate through 360 degrees or 2 pi radians, okay? So yes, you don't even have a new parameter here. Like you don't have another number to plug in. It's always going to be 2 pi radians, right? For every one revolution. And then you just divide that by time. So the numerator, we can rewrite that as theta, which is, the Greek letter we normally use for angles. So theta over t, right? And then in the next line, the formula here is omega equals theta over t. So omega is the letter we normally use for angular speed. Okay, it's the last letter in the Greek alphabet, which we've seen before, right? When we talk about sine and cosine graphs. I think with, well, especially with simple harmonic motion, right? In that context. Yeah, Dorothea.
So is theta just like the central angle?
Theta is, well, not necessarily the central angle, but it's because center angle, normally we would consider that to be a fixed angle, right? Like center angle is like 60 degrees, right? It wouldn't change. But here, theta, it's ever changing, right? Because it's a moving object, right? Or rotating object. So theta is just the angle that the disk or whatever the object rotates. All right, does anyone still need these notes? Please speak up now or type in the chat. No? Okay, I'm gonna move on then. So the last set of notes is with regards to how linear speed and angular speed are related. Okay, so to start us off, I want you to remember from geometry, so like freshman year, theta equals S over R. Okay, this is a formula that relates the central angle and arc length and radius. Okay, so the center angle to a circle, like if you have an angle, it's equal to the arc length, the distance along the circle, divided by the radius. Okay, and then if you cross multiply, you get S equals R theta. Okay, and we're going to use that to come up with a formula that relates linear and angular speed. Okay, so we're going to use the linear speed formula, V equals S over T, right? And then if you substitute R theta for S, you get V equals R theta or theta R over T. And then if you separate theta over T and R, you can see this as theta over T times R. But we know that theta over T is the same thing as omega, right? As we see here. All right, so instead of writing theta over T, we replace that with omega, which means that the linear speed is the angular speed times the radius. Okay, and this formula is gonna come up a lot. It's pretty handy, right? If you're given an angular speed, you can use that to solve linear speed. If you're given linear speed, you can use that to solve for angular speed. All right, does anyone need to copy this down?
Yes.
Yeah, okay, all right. Just let me know when you're done.
I'm done.
Okay, does anyone else still need it? No, okay, all right. So after this, it's just the classwork. And for the sake of time, we have about 10 minutes left in class. I'm just gonna go through the questions with you guys. Okay, so you might have already gone through it on your own, which is great, right? I posted the classwork on Google Classroom. But yeah, let me go through the solutions with you all so you know the final answer, right? Confirm. Okay, can someone read this first question for us?
A disc with 12 inches with a 12-inch diameter spins at the rate of 45 revolutions per minute. Find the linear and angular speeds of the disc in inches per second and radians per second, respectively.
All right, thank you for that. Okay, so two things: we have to find linear speed and angular speed, and just note the units. So it's inches per second and radians per second. Okay, so note that the given information is 45 revolutions per minute, right? So we're gonna have to change it to seconds, and yeah, diameter is 12 inches. Okay. Anyhow, given that, we have linear speed is S over T, right? Arc length over T. So using the formula from before, right? And I believe it's pretty intuitive. 45 revolutions, right? That's what we're given per minute, okay? Now I'm gonna change it to 60 seconds because again, the final answer should be written in seconds. Okay, so it's 45 revolutions times 2 pi r. R in this case would be 6 or 6 inches, right? Because diameter is 12. So it'd be 45 times 2 pi times 6, which is 12 pi. So 45 times 12 pi divided by 60 seconds. Okay. And you can simplify that. So 12 over 60, that's 1/5, right? And then 45 divided by 5, that's 9. Okay. So we're going to end up with 9 pi, right? Don't forget the pi. So we're gonna, yeah, our first answer is 9 pi inches per second. Okay. For the angular speed, it's theta over t. And, angular speed is actually easier to solve because you don't have to think about like, it's always like 2 pi radians, right? So there's always gonna be 2 pi here. But the variable in question, the number that we could plug in is the number of revolutions. In this case, it's 45. 45 revolutions times 2 pi over 60 seconds. 45 divided by 60, you can see that as, 3/4, right? If you divide both top and bottom by 15. So 3/4 times 2. So 3/4 times 2, that'll be 6/4 or 3 over 2, right? So 3 pi over 2 radians per second. Okay. Now, another way to solve this, we can use the last formula that we saw, which is V equals omega R. And you can solve for omega using, using this formula, divide both sides by R, you get omega equals V over R. And that's, V, we know that's 9 pi inches per second, right? And then R is 6, right? 6 inches. And then you get the same thing, 3 pi radians over 2 seconds, or 3 pi over 2 radians per second. Okay, but yeah, either way you get the same answer. Yes, Yusuke, question.
Yeah, so if like this type of question comes up on a test, would you like specifically tell us to like use a specific formula, or does it not matter which way we do it? As in, like, if we use the linear and angular speed formulas, do we not have to use the combined one, the V equals omega times revolutions one? Or
I mean, you should be comfortable with both. But yeah, I'm just showing you, like, sometimes it might be easier to use this formula to solve for one or the other. Like, if you have like one of them, then you can solve for the other one easily using this formula.
Okay, thank you.
Okay, does anyone still need this solution? No? Okay. If not, then can someone read question 2, please? Right here. Let's go to, yeah, good.
Oh, sorry. A woman is riding a bicycle whose wheels are 30 inches in diameter. If the wheels rotate at 150 revolutions per minute, find the speed at which she's traveling in miles per hour. Round to the nearest tenth.
All right, thank you for that. Okay, so this problem is actually a dimensional analysis question, meaning we just have to convert a lot of units, right? You might have already seen this type of question in chem class or physics class. Okay, but yeah, outside of that, it's not that difficult. So if you already know how to do that type of question. All right, so first thing to discern is that this is a linear speed that we're talking about, right? So miles per hour, right? That's a linear speed, not an angular speed, right? Because otherwise it'd be an angle measure, not a distance measure. Okay, so V equals S over T is the form we're going to start off with. And we're given that the wheels rotate 150 revolutions per minute. Okay, so we're going to use that same formula, right? Number of revolutions, in this case 150 times 2 pi r. R in this case is 15 inches, and divide that by 1 minute. Okay. From there, we just have to convert into miles per hour. So right at this point, we have inches per minute. Okay, but we have to convert that to miles per hour, right? That's what they're asking for. Okay, so essentially, all we're doing is multiplying by 1 every time. And what I mean by that is 60 minutes is equal to 1 hour, right? So it's 60 minutes divided by an equivalent measure, 1 hour, which is just 1, right? Anything divided by itself is 1. And that's how we're going to convert this to miles per hour. Okay. So I multiply by 60 minutes over 1 hour first to get rid of the minutes, right? The minutes unit divides out. And then we'll be left with inches per hour. Okay, so that's where we are at this point. Next, I'm going to get rid of the inches to get to feet, right? So I'm going to multiply by 1 feet. Well, 1 foot is equal to 12 inches, right? So I'm going to multiply by that conversion factor. And the only other question you really have to ask yourself is, how do I orient the fraction, the unit conversion factor, right? So to answer that, you just have to make sure you divide out the units, right? So if the inches is in the numerator, then if you're dividing that out, the conversion factor has to have the inches in the denominator, okay? So I'm going to multiply by 1 foot over 12 inches, right? And then at this point, we would have feet per hour, okay? And then the last thing we have to do is convert to miles per hour, okay? So now that we have feet per hour, 1 mile is equal to 5,280 feet. I did include that outside information on the classwork worksheet itself. I didn't write it here, but yeah, it's on the worksheet. But yeah, 1 mile is equal to 5,280 feet. And with that, we would divide out the feet unit or the foot unit, right? And then we would get miles per hour. And if you plug this into your calculator, right, multiply this all out, 150 times 2 pi times 15 times 60, all that divided by 12 times 5,280, you're going to get about 13.4 meters per hour. Oh, sorry, miles per hour, not meters, miles per hour. The only thing, just be careful with the calculations because you first have to multiply 12 times 5,280, and you know whatever that product is, use that to divide. Okay, so I'll put the 12 times 5,280 in parentheses. All right, does anyone still need this? No? Okay. Not, all right, let me go through question 3 really quickly. So it says a boy rotates a stone in a 3-foot long sling. So radius is 3 feet at the rate of 15 revolutions every 10 seconds. Find the angular and linear velocities of the stone. Okay, so for this one, I start off with the angular speed, right? It's theta over t. So 15 revolutions over 10 seconds. So let me say 2 pi radians here. Actually, I think it'll be clear if I get rid of this step. Okay. Yeah, so 15 revolutions, and every revolution has 2 pi radians, right? So in the numerator, you're going to get 30 pi radians, and then divide that by 10 seconds. So your final answer for the angular speed is 3 pi radians per second. Okay. For the linear speed, I'm going to use the formula V equals omega r, the one that relates angular and linear speed. Right, so omega, as we solved, is 3 pi radians per second. Multiply that by the radius is 3, and then you're going to get 9 pi feet per second, right? Because the radius here is in feet, so it'll be feet per second. Okay. All right, but yeah, that's actually all I wanted to say for today. As for announcements, there is SGI today at 2:47 in case you have questions, and then. Remember, our quiz is on Friday, so yeah, please do study for that. The topics list is on Google Classroom. Okay, but yeah, if you have no other questions, you're free to go, and I'll see you all tomorrow. All right, take care.
Have a
Thank
nice day, Mr. Lee.
Thank you.
All right, you're welcome. Take care.
Have a good day.
Thank you, you too.